Okay, in this video, I'm going to show you how to compute the bound price in Excel. Um, so I have uploaded this example file on Canvas, so you can feel free to download and follow through. So let's assume we have a bound that we are trying to price in Excel, and there's some input of this bound information right here in this blue box. This is a $1,000 par value bound, which means the bound has a face value of $1,000. And the coupon rate is 10%. So note that this 10% means for every year, this bound will pay you a total of 10% of the par value as its coupon payments. And the required rate of return of the bound is assumed to be 8%. And the years to maturity is 10, and this is the number of payment per year, which means how many times in a year this bound will pay you a coupon. And let's assume this is semi-annual coupon bound, which is the most typical bound in the real financial market. In that case, this bound will pay you coupon payment 2 times a year. Okay, so these are the basic information of the bound, and we are trying to figure out what's the price of this bound. So what you can do here is to use the PV function in Excel. So what you're going to do is to first click on the cell where you want to have the price displayed, and then press the equal sign, and you need to use the PV function. So just type PV here and type a parenthesis. Okay, so now you are going to input a couple of parameters so that Excel can generate the correct bound price for you. So the first input is, or say the first parameter is the rate. Okay, so this is the basically the required rate of return or the discount rate for this sequence of cash flow. And here the sequence cash flow is of course the bound coupon payment plus the final repayment of the par value. Okay, so here the discount rate needs to be related to the required rate of return. But note that you need to tell the Excel what is the required rate of return per period. Okay, since this bound is a semi-annual coupon bound, which means there are 2 payments per year. So here the rate needs to be adjusted. Okay, and the required rate of return here is 8%. But since we have 2 payment periods per year, so you need to adjust that by the number of payments per year. Okay, so it's D7 divided by D9 being the required rate of return or discount rate per period. Okay, now you hit a comma, and then you have the second input, which is the number of payment. Okay, since this is a bound that matures in 10 years with 2 times per year as payment. So here the number of payment is going to be 10 multiplied by 2. Okay, so that's a total of 20 payments. Okay, the next one is the payment. Okay, so that's the amount of payment that you're going to receive in each period. Now, this is related to the coupon rate. Okay, so like I said just now, every year you got to pay 10% out of your par value. So first you multiply your par value by 10%. However, remember that this is a semi-annual coupon bound, which means every time you got to pay half of this. Okay, so you need to divide this by 2, which is the number of payments per year. And then you hit comma again. The next value is the future value, which means what is the last payment at the maturity. Okay, and this is going to be your face value of the bound. Okay, so you are going to be paid $1,000 at the end of the maturity date. Okay, all right. So now we have everything ready, and you don't need to worry about the type because the type thing asks you to identify if those payments are made at the end of a period or at the beginning of the period. Okay, since this is a bound, and it's always being coupon payment are being made at the end of period by default. So don't worry about that, and just close the parenthesis, and you hit enter. Now you will see a negative value right here, okay? Simply because you have identified the last payment, which is the future value right here, being $1,000, which is a positive number. So that's why as the Excel computes the present value, it will tell you a negative value. So what you can do is just to add a negative sign in front of your formula, okay? And to make this number appears to be positive. Okay, now this is the approach that we can use to compute a regular coupon bound.